Hello friends, today I will discuss the numerical problems on super mesh analysis. So here the problem given is like this. Find the current I in the following circuit using super mesh analysis. If you look at the figure, we find here there are two voltage sources which are connected in parallel with the current source. See, this is 4 volts in series with 1 ohm resistor connected in parallel with the 2 amperes current source. Similarly, 2 volt source, 1 ohm resistance connected in series, and the combination is connected across the 2 amperes current source. If you look at this diagram, in the middle branch, we do not know what is the voltage drop across this. So once we do not know the voltage drop across this, we cannot use the ordinary KVL for this circuit. So we have to use a special method called super mesh method to solve this problem. So to apply the super mesh analysis to this circuit, we have to follow some algorithm or some procedure. So that procedure I will tell step by step first, and then I follow those steps to solve this problem. The first step is find the number of loops. So if you look at this, this is one loop, this is another loop. So the number of loops will become here 2. Next step is assign the loop currents. The third step is assign the voltage polarity across each element and write the current equation for current source. The fourth step is remove the current source which is common to the two loops, that is this. Then step 5, write the loop equations and solve for current I. So these are the 5 steps to be applied to solve this problem. So the first step is identifying the number of loops in the circuit. That is already over. That is, this is one loop, this is another loop. Then assigning the currents for each loop. This is the loop 1 and this is the loop 2. For loop 1, the current we are assuming here as I1 and it is flowing in the clockwise direction. In the loop 2, the current flowing we assume I2 and it is flowing in the clockwise direction like this. Next step is give the polarity for voltage across each element. So for this, we have to follow a certain procedure. If the current enters the passive element, that is assumed current enters the passive element first, then leaves, then the entering point of passive element, we call that as positive terminal, and whereas the other terminal we call as a negative. So in this loop 1, current I1 is entering here, so we put here plus and here we put negative. And the voltage source polarity do not change. It will maintain its own polarity as it is. That is, this is negative always, this is always positive. And here we have the current source. The current source also have the fixed polarity, so we cannot change its polarity. It will be like this only. Next, coming to the second loop. The second loop current is I2, and this I2 entering this passive element 1 ohm here. So entering the passive element will be treated as with positive polarity, and whereas leaving the 1 ohm resistor is given as negative terminal. So here, because I2 is entering the 1 ohm resistor, here we put here plus polarity, whereas here it is negative. Whereas this 2 volt source have the fixed polarity. This is always positive and this is always negative. So that step 3 is over. Assigning the voltage polarity across each element is over. Then we have to write what is called the current equation for the current source. This is the current source, and this current source direction is matching with the I2, and whereas I1 is flowing in the opposite direction in the 2 amperes current source. So I2 minus I1, or the resultant of I2 and I1, is nothing but 2 amperes. So that is why we are writing here I2 minus I1 is equal to 2. That is equation 1. So step 3 is over. Then step 4 is, so we have to remove this current source which is there in the circuit, which is in common between the two loops. So once we remove that, we get the circuit like this. And this circuit is called the mesh circuit. Remember here, though all the elements are in series, we are maintaining the previous current directions and previous current values as it is, and polarity also. So then once we have the circuit like this, so without disturbing these polarities, we have to apply the KVL for this loop, for this super mesh loop. So we start at one point. Say we start at this element, that is 4 volts source. So in the assumed current direction, that is I1, first enters here and it is finding here negative terminal. Next we are getting here positive terminal. So in the assumed current direction, if you find the negative terminal first and then positive terminal, we call that as voltage rise. And voltage rise polarity is treated as plus. So we put here plus 4. Then in the assumed current direction I1, first we are getting here positive, next negative. So when we get the positive first, then negative, we call that as voltage drop, and voltage drop will get the minus sign. So minus 1 into current is I1. So that is what we have written here. Then two elements are over. Next come here. So here the current entering this 1 ohm, and that is here plus first, plus next we are getting negative. And if you find the positive first, next negative, we call that as voltage drop, and voltage drop will get the negative sign. So we write here minus 1 into I2. So that is this. Next, here we have the positive terminal for the 2 volts, and this is negative. And in the assumed current direction I2, first we are getting the positive polarity, then negative. So going from positive to negative is, we call that as voltage drop, and voltage drop will get the negative sign. So minus 2, and we have covered all the elements. So is equal to 0, means algebraic sum of the voltages around a loop is equal to 0. That is nothing but KVL. So that is what we have applied for this loop. So then you simplify this. Once we simplify this, we get I2 plus I1 is equal to 2 ampere, 2. So then we say this is equation 2. We know equation 1, that is I2 minus I1 is equal to, and we know what is I2 plus I1, that is 2. And adding these two equations, so we get that I1 going to get cancelled. So we get 2I2 is equal to 4, and from that we get what is called the 2 amperes. I2 is nothing but 2 amperes. So what he asked is the current flowing in the voltage source 2 volts voltage source branch, that is this, and this I is nothing but this I2. So we say I2 is equal to I is equal to 2 amperes. Next, let us move to the another loop, another problem. So this is also a super mesh numerical problem given in the GATE 2010. Earlier we have seen two loop super mesh problem, whereas here we have the 3 loops, and we have to find here what is the power supplied by the voltage source 10 volts. Means we know the 10 volts here, we should know what is the current supplied by this. So once we know the current supplied by this 10 volt source, then we can say this voltage into that current will give us what is the power supplied by this voltage source. So for this also the procedure is same, the algorithm is same. So the procedure consists of several steps. The first step is identifying the number of loops. The number of loops here is 1, 2, 3. So the number of loops will become 3. Next, assign the loop currents. The third step is assign the voltage polarity across each element and also write the current equation for the current sources. So then fourth step is remove the current source which is there between every two loops, means this is one, this is another. So these have to be removed. Then whatever circuit that we get, we call that as super mesh circuit. Then for that super mesh circuit, we have to apply what is step 5 is write the loop equations and solve for the current that is supplied by the 10 volts supply. So we have seen the algorithm or procedure that we apply for this circuit one after the other like this. The first step is identifying the loops. We identified the loops, that is total number of loops are 3. This is the loop 1 and this is loop 2 and this is loop 3. Loop 1 current we are assuming here as I1 and flowing in the clockwise direction. Similarly, loop 2 current we are assuming it as I2 and flowing in the clockwise direction. Coming to the loop 3 current, this is also flowing in the clockwise direction and its value or we are assuming as I3. And then we have to assign the voltage polarity across each element. So here let us take this loop 1. So active sources do not change its polarity, it is always like this only. So go to this element here. So I1 enters here first, then leaves here. So when the I1 enters here, we put here positive polarity, whereas here we put negative terminal. So similarly, same I1 enters here 1 ohm, so we put here plus and here we put here negative. Similarly, that I1 is entering here this 1 ohm, so we put here plus and then put negative. Then go to the second loop. This is the second loop and start at one point. Let us say we start here. This is 1 ohm resistor. This I2 is entering here, so we put here plus and leaving here, so we put here negative. Same I2 is flowing here, entering here, so we put here positive, then here we put here negative. Then this is the active source, so we cannot change its polarity, it is always like this. Similarly here also. Then coming to the third loop, so we start at one point. Let us say here this I3 entering this 1 ohm here, so we put here positive and here we put here negative. And this is the voltage source whose polarity do not change with the current direction assumed. Similarly, this 2 amperes also do not change its direction as per your current direction. So next step is writing the current equation. So this is nothing but the third step. So this is I1, this is I2. The direction of I1 is opposite to the direction of 1 ampere current source, whereas I2 is same as that of the 1 ampere current source. So the difference of I2 and I1 is nothing but 1 ampere. So we write I2 minus I1 is equal to 1 ampere. So we say that is equation 1. So there is another equation for another current source. Here if you see here, I3 direction and 2 amperes current source direction are one and the same, whereas I2 is flowing in the opposite direction. So the difference of I3 and I2 is nothing but 2 amperes. So we write here I3 minus I2 is equal to 2, that is equation 2. So third step is over. Next fourth step is remove the current sources. So this and this we remove like this. And we do not change any other parameters in the circuit. And we call this as the super mesh circuit. So here if you observe properly, there is one element which is hanging like this. So no current flows for this. So we do not apply any KVL for this element. Whereas for other elements they are connected each other. So that is forming a loop. So for that loop we can write the loop equation, that is we apply the KVL to this loop. So look at this. You start at one point. So let us say in the second loop we start. So this is the 1 ohm resistor and we are getting here plus first and next negative in the direction of I2. So when the polarity is first positive and then negative in the assumed current direction, we call that as voltage drop, and voltage drop will get the negative sign. So we write minus 1 into I2 like this. Next, we have another element called 1 ohm. Here also current I2 uh, flows like this. So in this direction, first it faces the positive sign here, next negative. So getting the positive sign first, next negative, we call that as voltage drop, and voltage drop will be assigned as negative sign. So we put here minus 1 into I2. So that is what we have written here. Next, these two elements are over. Next, come here, and here the current flowing is I1. So here this I1 is facing first positive terminal, next negative. Going from positive to negative is called the voltage drop, and voltage drop will get the negative sign. So we put here minus 1 into I1. So that is what we have written here, minus 1 into I1. Next, same I1 facing the first plus terminal, then negative. Going from positive to negative, we call that as voltage drop, and voltage drop will get the negative sign. So we write here minus 1 into I1. So that is what we have written here. Then you have another element here. So here also I1 enters here and facing the positive terminal, next negative. Going from positive to negative in the assumed current direction, we call that as voltage drop, and voltage drop will get the negative sign. So here also we put minus 1 into I1. Next, this is not useful because no current flows here. It is just hanging branch. So then we go here like this. So there is no passive element here to write. So what is the element that is there? So here we have the voltage source, and in the assumed current direction I3, first we are facing plus sign here, next negative terminal. So getting plus first, next negative means it will be treated as voltage drop, and voltage drop will get the negative sign. So we put here minus 10 is equal to 0. So we have written the loop equation for this super mesh circuit. Then we simplify this. So once we simplify this, we get minus 2I2 minus 2I1 is equal to 10. So we can further simplify this. Then we get I2 plus I1 is equal to minus 5. And we say this is equation 3. And we know what is equation 1. So we add equation 1 with the equation 3. So equation 1 is nothing but I2 minus I1 is equal to 1 ampere. So we write I2 minus I1. So I3 is I2 plus I1. So we are right and adding this plus I2 plus I1 is equal to 1 minus 5. That is what we have written here. So then simplify this. Then we get what is called the 2I2 is equal to minus 4. Once we simplify further, we get I2 is minus 2 amperes. So then we know what is I2 and we know what is the equation 2. That equation 2 is nothing but I3 minus I2 is true. So I2 just now calculated. You substitute that value here so that we can calculate what is I3. So I3 minus I2 value is found as minus 2. So we put it as it is equal to 2 in equation 2. Then we simplify this. Then we get I3 is equal to 2 minus 2, that is equal to 0 amperes. So what is this I3? This I3 is nothing but the current that flows from the 10 volt source, and that 10 volt source supplying zero current. That I3 is nothing but the current supplied by the voltage source 10 volts. So once the current supplied by the 10 volt source is 0, then we can write the power supplied by the voltage source is equal to 10 into I3. So I3 value is 0, 10 into 0 is equal to 0 watts. So this was given as A option in the multiple choice. So So we have seen what is mesh analysis, how to use that for two loop circuit, similarly for three loop circuit.